This is the editorial for Codeforces round 982 div 2. Question C, add zeros. The question states that we are given an array A containing n integers initially, and in one operation we have to do the following. Choose an index I. So choose a valid index, so the index must be greater than or equal to 1 and less than or equal to the size of the array. So this is one based indexing. So choose a valid index, not valid just because it exists in the array, but this has to be satisfied as well. The value at index A is equal to size of the array plus 1 minus index. So if we are choosing the value at index I, then we have to make sure the value is this. And if it is this, we have to append I minus 1 zeros to the end of the array. So if the element at fourth index, keeping one base indexing element at fourth index satisfies this condition, then we add three zeros to the end of the array, right? The problem is clear. So after performing as many operations as we want, what is the maximum possible length of the array? So we have to maximize the length of the array, right? So 2, 4, 6 to 5, let's pick this example, 2, 4, 6 to 5. So the size of the array at first is 5. So what should be the value? So index 1, 2, 3, 4, 5. So first index should be 5 minus 1 plus 1, that is 5. Second one should be 5 minus 2 plus 1, that is 4. This one should be 5 minus 3 plus 1, that is 3. Similarly, 2 and 1. So ascending order, of course. Since we are increasing the index in ascending order, it is decreasing. It is decreasing order. So 5, 4, 3, 2, 1 now. Look at this. 4 is maxed and 2 is maxed. So you can either choose second index or you can choose the fourth index, right? Because they both satisfy the conditions. Now, let's say you pick 4. If you pick 4, then since 4 is at index 2, you add 1 0 to the end of the array. So the array size becomes 6. So this becomes 6 0. So this becomes 6 5 4 3 2 1. Now nothing matters. See, nothing matters. And remember one thing. So if you have used 4 to get 0 to the end of the day, you can not use 4 again because that won't be valid. Because if something was valid for suppose size 7 and we have increased the slice to 7 plus x, keeping the last value same, so 4 is 4 only, right? So if we have increased 7 to 7 plus x, we can't, if we have used 4 in 7 and not changed it, we can't use it in 7 plus x. Similarly, 4 was used, but this time 4 we can't use. And look at this. So there is nothing that matches now. 6 is not 2, 5 is not 4, 4 is not 6, 3 is not 2, 2 is not 5, 1 is not 0. So the maximum value we could have found is 6. But remember, we had 2 as the choice as well. So let's pick that. 4, 6, 2, 5, right? So 5, 4, 3, 2, 1. See, we can pick 2 as well. If we pick 2, 4 is the maximum. 4 is the index of 2, so we can add 4 minus 1, that is 3 zeros at the end of the array. 1, 2, 3. The new size of the array is 8. So this goes out. This becomes 8, 7, 6, 5, 4. And for zeros, we don't care because the minimum value possible is 1 here, and so 0 can't be picked. So 8, 7, 6, 5, 4. Now see, 6 also matches, right? And 6 is at index 3. So we add two zeros to the end of the array again, two zeros. Now the size is 10. So 10, 9, 8, 7, 6. Now nothing matches. So our operation stops here. We can't do further operations. So the maximum size we obtained was 10, 10, right? So 5, and we added 5 zeros. So 10, and we can see 10 is the answer to this question. Now, how did we do this? Starting index. So see one thing, which is this requirement for this is 5, requirement for this is 4, requirement for this is 3, requirement for this is 2, requirement for this is 1. Now, the requirements can only increase, they can't decrease, because if you increase the size, you are going to increase the requirements. If it was 5 and if we increase the size to 7, this will be 7. It won't ever be less than 5. So we can only increase the requirement. So if 2 was smaller than the requirement, 2 will never be used. Right? So now keep track of things which are mm, greater than or equal to the requirement, and then we go on. So 2 is smaller than the requirement, so we don't care. Now 4 is greater than or equal to, so we need to add 0 to 4 to make it equal to the requirement. Now 6 is greater than 3, so we need to add 3 to the requirement to make it equal to 6. Now 2 is equal to 2, so we need to add 0 to the requirement to make it equal to 2. And 5 is greater than 1, right? So we need to add 4 to the requirement to make it equal to 5. Now what does this addition mean? Means the size of the array needs to be increased by 0, size of the array needs to be increased by 3, size of the array needs to be increased by 0, size of the array needs to be increased by 4. So this means 0 needs to, the size of the array needs to be increased by 0, the size of the array needs to be increased by 3, the size of the array needs to be increased by 0, the size of the array needs to be increased by 4. Now another thing, so if we pick 4, we need to increase the size of the array by 0, right? Because in time requirement is already matching. And what will be the new size of the array? Uh, New size of the array would be increased by index of 4 minus 1, so 2. So the new size of the array would be increased by 1, right? Because we are adding 1 0 to the end. So the current size is 0 plus the current size, the original size, and after applying the operation at 4, we are going to increase the size of the array by 1. Now think about something. This didn't have a requirement because requirement is greater than our array's number. Here requirement was 0, here requirement was 3 greater than the size, because if we increase 3 up to 6, so the size of the array is increased by 3 elements, 6 will be valid. If the size of the array is as it is, 2 would be valid. If the size of the array is increased by 4, 5 would be valid. Now see one thing, there is a relation relation between 2 and 6. How? See, so if we pick 4, 4 needs 0 elements to be added to the end of the array, and 4 will add 1 element to the end of the array. Since index is 2, so let's write the index of there 1, 2, 3, 4, 5. So 4 has no requirements, so 0, and it will add 1 element to the end of the array. 3, for 3, the size of the array needs to be increased by 3. So size of the array needs to be increased by 3. and afterwards, the if the size of the array is increased by 3 and 6, the index of 6 is 3, right? So it will add two elements more to the array. So if the size of the element was 3 and 6 added two more elements, the size of the array would be 5. So when the size of the array was 3, 6 was valid, and when 6 was valid, 6 added two zeros to the end of the array. So size got increased by 2 again. So 3 original size plus 3 became original size plus 5. For 2, for 2, uh, 0 elements were required to be added because it is already satisfied. And then look at this, index of 2 is 4. So we added 4 minus 1 zero to the end of the array. So the size of the array got increased by 3. For 5, we needed 4 elements, and 5 index is 5, so it will add 4 more elements to the end of the array. So 8. Now, of course, we can just think about picking the maximum size possible, 8, but we need 4. So the size of the array needs to be increased by 4 for us to achieve 8. We can't just pick the size of the array to be 4 all of a sudden. So we have to start from 0. So what is this relations? The relation is um, original size, original, no, not original size, original requirement plus increment, and form a relation from this to new size. New size. So the requirement for this one was 0, new size was 1, requirement for this was 3, new size was 3 plus 2, that is 5, requirement for this was 0, new size would be 3, requirement for this was 4, new size would be 4 plus 4, that is 8. Remember, we have to start from requirement 0 because we can't just add more elements and then start from there, right? We have to start from original array. Um, we have to first make sure this condition exists. So in the base array, in the base array, this and this match the condition. So we have to start from there. We can't start from there because initially the conditions are not matched. Initially this condition is not matched. So let's again make this. So 0 to how many elements it increased? 1. Then 3 requirement to it increased it to 5. 0 requirement, it increased it to 3. 4 requirement, it increased it to 8. Now see, if we pick this one at starting, the size of the array is increased by 3. And if the size of the array is increased by 3, we can pick this and the size of the array would be increased by 5. Right? There's a correlation. Let's think about this. So suppose 0, 1, 5, 7, 2, 10 to the power 6, suppose, and 1, 5. So the biggest correlation is we can start from 0, increase the size of the array by 1, pick 1, and increase the size of the array by 5, pick 5, and we increase the size of the array by 7. So the size of the array becomes original size plus 7. No matter what is the biggest size possible, 10, even if it is 10 million, we can't pick it because we can't start from 0 and go to 2, right? 0 to 1, then 1 to 5. There is nothing such as 1 to 2. So we can't increase the size of the array by 2. So we can't use this relation. We can only use the relation uh, x to y if we can increase the size of the array by x. So the main things to remember here are, if we make a correlation like uh, a, b, c, d, as in this case 0, then 1, then 5, then 7, we have to make sure this correlation starts from 0, or else we won't be starting from the original initial array. We will be starting from increment, and that increment is not possible without starting from the original array. Right, so for each element, for each element 2, 4, 6, 2, 5, mark how many times do I need to increase the size of the array to match the requirement. So as we remember 0, 3, and 0 and 4, we need to increment the size of the array by this much margin to use these numbers. So let's look at the code. What the code does is, first of all, we take n, and I'm doing n plus plus. Why I'm doing n plus plus? Because it is one base indexing, right? One base indexing. So I'm making a vector long, because 10 to the power 12 is the maximum possible value for a, and then I'm using a for loop from 1 to n for one base indexing 1 to n and taking value as input. Then I'm taking a multi-map. Why? Because there can be values like here 0 to 3, 0 to 5. So if we take a map and at first we insert 0 to 3 and then we insert 0 to 5, 0 to 3 will be eliminated. So we are taking a multi-map and we are running a for loop again on the array, and we are decreasing n, because when we increased n, when we increased n, we increased it decreasing n because we need the length of the array, right? If we are increasing here n, we are increasing the length of the array as well. It decreased n first, and then ll is equal to n minus I plus 1. That is, this is the requirement, right? This is the requirement. This is the requirement. This is the, you can also name it requirement. Requirement. And what we are checking is if vi minus requirement is greater than 0. That is, vi is greater than requirement. Because if vi is smaller than requirement, we will never use that value. So if vi is greater than requirement, what I'm doing is, how many times is it greater? Can I use it in the original array? Do I need to increase the array size by 1, by 2, by 3? By how many times? So how many times is our value greater than requirement? And afterwards, vi minus requirement plus I minus 1. What does it do? If this is how many times we need to increase the array size, this is how many times we will increase the array size. So suppose we pick uh, 6. Here requirement was 3, and since the index was 3, we'll increase the array size by original size plus index minus 1. So if the requirement was here, we'll pick the array requirement plus index minus 1 and insert it into the multimap and increase the value of n by 1 for checking in the for loop. Afterwards, make an array dp, make a map dp, and set the value of dp of 0 to 1. dp is nothing but making connections from 0. So 0, 1, 2. dp is checking if there is a connection from 2 to 0. First we make a connection from 1 to 0, then we make a connection from 2 to 1. So first we make sure 0 is connected to 0, then we set a rest. This will be our answer, and we iterate on the map and we check if the connection from 0 is there. At first 0 is connected to 0, so of course 0, we will find 0 in the map, and when we find 0, we'll set its value in the map as the answer's maximum, because if 0 exists, the value that 0 can increment to the size will be the maximum size possible, and we make sure to connect the element to 0. So 0 to 1, 1 to 5. If 0 increases the size by 1, then 1 is connected to 0. Then again, if 1 picking 1 increases the size by 5, then 5 is connected to 1 and hence to 0. And we are only using the value if it is connected to 0. Afterwards, this is n minus 1, because we increased n plus plus, we increased the size of the array by 1. So here we are decreasing the size of the array by 1 again, because this is the original size of the array, and this is the maximum size by which we can increment the size of the array. So after making connections from 0, 0 to 1, 0 to 5, 0 to 3, the maximum size possible would be 3, right? 3 here would be stored in bells. And let's do one thing. N minus minus, this is the original size of the array, and we are increasing the size of the array by bells times. That is the code for this question. Thank you.